We want to find the secant of theta. All right, so this requires a lot of a lot of stuff to remember, a lot of pieces to put back together. So the problem looks like this, and we want the secant of theta. Now I remember that secant is reciprocal of cosine. Cosine, so katoa. Cosine is adjacent over hypotenuse. So I'll be doing hypotenuse over adjacent, right? You okay with that? Now the problem is, I've got my adjacent side. There's theta, so this is my adjacent side. Does everybody understand that? That's adjacent. This would be opposite. But I don't have my hypotenuse, so I'm going to do my Pythagorean theorem and get my hypotenuse. So it's going to be the square root of 181. 100 plus 81. So my secant is the square root of 181 over 10. All right, who else? You're on the problem a day sheet or here. Something you need your memory jogged because you just can't remember.
11 on this.
Huh?
11 on the quiz.
11 on the quiz. 11 on the quiz. Draw a course of 162. Remember, there are basically two ways to draw angles. If I said draw 162 degrees, if that's all it said, then you would start right here. This is where we start on the positive x-axis, and you would go counterclockwise 162 degrees. This would be an angle of 162. That is not a course of 162. When you are dealing with directions, then due north is 0, and we proceed this way. Anytime it says course or direction or heading, anytime those kinds of words are used, this is your framework. So 162 would look like this. This is a course of 162 degrees. All right, so you've got to know, you got to be familiar with both of these setups. This is only used, look, it's a compass. So if it's a direction problem, you're going to use your compass. Otherwise, you're going to do it in standard position. Remember that now?
Yeah.
Okay, what else? Yeah, Rosie.
Number 15 on the bottom of the sheet.
Give me that problem. What is that problem?
Find two angles coterminal with 9 pi over 7.
Coterminal 9 pi over 7. Now, in order to do this problem, it's got a little bit of a snag in there. The angle is in radians. But in terms of being coterminal, we're finding coterminal angles. The process is the same. Coterminal angles are angles that start and stop in the same place. So a very simple example would be 60 degrees and negative 300 degrees. They start and stop in the same place. To find coterminal angles, you either add or subtract revolutions. So 60 minus 360 gives you negative 300. 60 plus 360 will give you 420, right? Which would start and stop and just go all the way around and back up to there. That's how we find coterminal angles. So first things, kids, you got to have the big picture. The big picture is to find coterminal angles, you add and subtract revolutions. If you're in degrees, that's easy. You add and subtract 360. What is a revolution in radians? 2 pi. So if I have a radian measure, I am going to add 2 pi and subtract 2 pi. It's as easy as ever, it's just fractions, so I'm going to need a common denominator. Coterminal, add, subtract, revolutions. So getting a common denominator here, this would be 14/7, right? So 9 plus 14 would be 23 pi over 7. There's one of my coterminal angles. Now I'm gonna subtract 14/7, getting a common denominator. So 9, that would be negative 5 pi over 7. There you go. There they are. To find coterminal angles in degrees, we add and subtract 360. In radians, we add and subtract 2 pi. All right? Hopefully some of that's starting to come back out of the fog. So we need to get some more. So what else? What else is a little foggy? John, don't just stare at me, honey. Because I know if I gave you that quiz tomorrow, you wouldn't do very well, right? So something on there we need to talk about. Blakely?
Number 3 on that, on page 2, it says a bicycle with a 24-inch diameter tire
Okay, 24-inch diameter, okay?
is traveling at 8 miles per hour.
8 miles per hour.
How many revolutions does each tire make per minute?
Okay, so I'm looking for revolutions per minute. So this is basically kind of what factor label kind of thing. I mean, I just gotta get from one unit to another unit. So here we go. I'm gonna start with something. 8 miles per hour. 8 miles, 1 hour. I'm starting with that. They gave me that information. I want to get to revolutions per minute, so I need minutes, right? So that's easy. I know there are 60, oh wait a minute, I don't want to do that. I know 1 hour is 60 minutes. Is that okay? And then now these are going to cancel. So now I've got at least per minute. I need to get to revolutions. This stands for revolutions. I need to somehow get from the diameter of the circle to a revolution. Now, I want you to think about what I just did. I said I need to get to revolutions. This is a revolution, right? But in terms of the tire, this isn't the diameter. What's this in terms of the circle? Circumference. So 1 circumference is 1 revolution. Would you agree with that? Okay, so let's get the circumference down here. I have a 24-inch diameter. So 1 revolution would be, I'm going to go ahead and change that into feet. That would be 2 feet. Would you agree with me? So what's my circumference? 2 pi r, 4 pi? Would you agree that 1 revolution is 4 pi feet? A circumference, which is 2 pi r, is 1 revolution. Why did I put 1 over 4 pi and not the other way around? Where I want to end up with revolutions per minute, right? Now this is great. I've got revolutions per minute, but I've still got miles and feet to deal with. So what do I know? There are 5,280 feet in a mile. So 5,280 feet in 1 mile. Now the miles are going to cancel, the feet are going to cancel, and I am left with exactly what I wanted, which is revolutions per minute. Now you guys have done enough of this in your life. I think you don't have any trouble with this, and I think you don't have any trouble with this. What you have to remember in these problems is this relationship right here, and it makes perfectly good sense. A revolution is a circumference. So if you need to get revolutions into your problem, you need to put in the circumference. Okay? John? All right, who else? What else is a little bit foggy? Yeah, Kate.
Number 13 on the obligation.
Okay, what's that problem?
State the sign plus, negative, or 0 if sine of 100 degrees.
So sine 100 degrees, and we're just going to figure out if it's positive, negative, 0, or undefined. Actually, would be another option, even if I didn't include it. Okay? Now, this hinges totally on where 100 degrees is when you draw it. Where is 100 degrees when you draw it? It is in quadrant 2. Right? Now, if you were to make your butterfly bow tie triangle, forget the numbers. The numbers aren't what's important. Positive, negative. This, of course, would be positive because the hypotenuse is always positive. This would be negative, and that would be positive. Would you agree with me? I don't need the numbers. I just need to know positive and negative. Now, I need the sign of that. Sine is what? Look at the origin. Sine is opposite over hypotenuse. So for quadrant 2, any angle in quadrant 2, the sign is going to be a positive number. Would you agree with that? Cosine, on the other hand, would be negative, because cosine is adjacent over hypotenuse. Another way to think about that is sine, in your definitions, sine is associated with y, and cosine is associated with x. The SIGN of the SINE is going to depend on the SIGN of y. The sign of the sine depends on the sign of y. If y is positive, sine is positive. If y is negative, sine is negative, because sine is basically y. Cosine is basically x, and tangent is a combination of the two, y over x. Okay? Some of you are just staring at me blankly. Tomorrow will be all fresh tomorrow, right? All right, can you think of anything else we need to touch base on before, anybody know what time this up here is over? 20. Good. Oh, we've got plenty of time. What else do we need to touch base on? Pretend you were going to walk in tomorrow and I'm going to give you a quiz. What on there could you not do?
Number 4 on the quest.
Which number 4 on the quest? Number 4 on the quest. Okay, this is a good one. 4 cosine 3x. Now, on the quest, I did not ask you to actually graph it, but we're going to go ahead and do that right now. We're going to answer the question first. Is it 2/3 x? No, it's 3x. All right, we're going to go ahead and answer the question first, which is simply, what is the amplitude in the period? And then we're going to sketch it, because we need to know how to do that. All right, so here we go. Amplitude, all right, this is my regular old cosine curve. This is what I have memorized. That's what I have memorized. The amplitude is the height of the hills or the depth of the valleys. The amplitude of a normal cosine or sine is 1. Everything goes up 1, down 1, up 1, down 1. When you put a number out here in front, it multiplies the amplitude. So instead of going up 1 and down 1, you're now going to go up 4 and down 4. So your amplitude is 4. The normal amplitude is 1. This number multiplies the amplitude. 4 times 1 is 4. Now be careful. It's possible that that is a negative number. Do you remember what that does? Flips it upside down. The amplitude would still be positive 4. Because even if it's upside down, the hills are still up 4 and the valleys are still down 4, okay? Don't ever put a negative number here. Now, the normal period, that is top of hill to top of hill, one cycle of the curve, is 2 pi. 1 revolution, 1 time around the circle. When you put a number here, it divides the period. So the normal period of a sine or a cosine is always 2 pi. That's always the starting point. You put a 3 in here, so your period for your equation is 2 pi over 3. If this had been a 5, it would be 2 pi over 5. Chandler, are you awake, honey?
Yeah.
I can't tell when your head's down and your eyes are shut. Now, I'm going to draw it. Okay, you got this figured out? These are the rules. Now, when I draw it, I'm going to draw that exact picture. But the labels are going to be different. Instead of this being a 1 and a negative 1, you already told me it's a 4 and a negative 4, right? And instead of stopping at 2 pi, I'm going to stop at 2 pi over 3. So actually, this curve is a lot shorter. Now, the bottom of the valley is right in the middle of the 2 hills. If that's 2 pi over 3, what's this going to be? 1 pi over 3. Forget the pi's and think of fractions. If that's 2/3, what's half of 2/3? What's right in the middle of 0 and 2/3? 1/3, right? Now, what's right in the middle of 0 and 1/3? 1/6. This one's a little harder. You want to just count? You can. This is 1/6, 2/6. So this would be 3/6 or 1/2. And then that's 4/6. There would be your picture. You okay back there, Stu? All right, let's do one more. One more, and then I will quit blabbing at you. Haven't you missed it, though? You've missed it. I bet there were mornings you woke up and said, hey, I wish I could go to Precal today. Right? No?
Can you do number 13 on the quest?
13 on the quest. This is another positive, negative, or whatever. Cosine, we talked about this a minute ago. What does cosine depend on? Which letter, X or Y? X. Cosine's X. So what I really want to know is if I drew 2017 degrees, would X be positive or negative? That's the deal. Well, 2017 is big. It's a lot of spins. So I'm going to go ahead and divide out all of the extras. So 2017 divided by 360, let's see, 5, 6, 5. Must be 5 times it goes in there. And leaves me with 217 degrees if my arithmetic's right. So what does 217 look like? It's in the 3rd quadrant. Now you said cosine is X over R. It depends on X. Tell me about X in the 3rd quadrant. It's negative. It's negative. If X is negative, the cosine's negative. The sine would also be negative, right? But the tangent would be positive, because tangent is y over x. Negative over negative would be positive. Okay? Now, you had an assignment. If you did that problem today and you have it done, you can make sure your name's on it, put it up here in a pile. If you didn't, I'm not holding it against you, but you were asked to do that, and I think some of you responsible people did, and you irresponsible people didn't. But go ahead and you haven't done any homework all year. So what do you think? Okay, so turn that in. Also,